Hello everyone, I'm going to show you guys how to do features of exponentials and logs in Delta Math. This is going to be your assignment today. Here we go. So this is an exponential function. We know that because it's 1/3 to the power of x. It doesn't have a log in it. This is going to have a horizontal asymptote at -5. So horizontal at y equals, because it's going through a tick mark on the y-axis, -5. The range of the function is going to be, it doesn't exist down at -infinity. Coming up, it starts existing at -5 and then exists until positive infinity. So -5 to positive infinity. And it is decreasing. So if I started from left to right, you would be going down forever. So this is decreasing on its entire domain of -infinity to positive infinity. This is for all exponential functions. And the end behavior is, as I go to the left, the x values are getting much smaller, more negative. So it's going to be -infinity on the left. And as I move to the left, my graph goes up. So that means that the y values are going towards infinity. And the end behavior on the right, as my x values get really big, so my y values are going to approach -5. So they're going to be coming down, and then they kind of level off here at -5 as it goes to the right. All right, let's see how we did. There we go. So the only number that you should be using here is -5. That can help you out with the range of the function and the end behavior. Okay, let's do another one. Had to make sure I was recording, which I am. We can do another one of these and then we'll do some logs after that. So I know this is an exponential function because it doesn't have a log in it. So this is an exponential with a horizontal asymptote at, looks like -1. So y equals -1 because it's going through a tick mark on the y-axis. Horizontal, y equals -1. The range of the function is it doesn't exist in -infinity, starts existing at -1, and then exists in positive infinity. So -1 to positive infinity. And if I were on a roller coaster starting from left to right, I'd be increasing all the time. So it's increasing on its entire domain of -infinity to positive infinity. This is for all exponential functions, so you can just put that in there. The end behavior, as I move to the left, so as my x values get really, really, really negative, my y values are going to go towards -1. So they're just going to be leveling off here at -1. So as x gets really negative, y goes to -1. And if I move to the right, as my x values get bigger, my y values also get bigger. So as x goes to infinity, y also goes to infinity. All right, let's do another one. Maybe try to get some logs in here. So this log, first of all, I know it's a logarithmic because it says log base 3 of x. And it is going to have a vertical asymptote. So you can see it doesn't actually go past 0 on this graph. This is an x value 0 because it's going through a tick mark on the x-axis. So vertical asymptote of x equals 0. The range of the function, it does exist in -infinity, and it actually exists in positive infinity as well, because this is going increasing forever. So this is true for all logarithmic functions. It's flip-flopped of the exponential functions. And it is, if I was on a roller coaster, I would be increasing the whole time. Pretty scary roller coaster. So it'd be increasing on its entire domain of, it doesn't exist over here in -infinity. It starts existing at 0, and then it exists in positive infinity. So it's going to be 0 to infinity. The end behavior on the left, the lowest x value I could possibly have is 0. That's it. I can't go anywhere further than that. So as x goes to 0, the y values are going down. They're decreasing. So they're going down towards -infinity. And as I move to the right, as the x values get bigger, so I can go as far this way as I want, the y values are also getting bigger because this function is increasing. So as x goes to infinity, y also goes to infinity. All right, maybe one more problem with the logs. I can already tell -3 is going to be the number I want to use here because it's the opposite of what's inside with the log. So let's go ahead and go down. This is a logarithmic function with a vertical asymptote at x equals -3, because that's a tick mark on the x-axis. X equals -3. The range of the function, this is true for all logarithmic, -infinity to +infinity. It exists everywhere. And it is, if I started from left to right, decreasing on its entire interval or domain. And the domain here, I can't go past -3. So it doesn't exist in -infinity over here. Starts existing at -3, and then it exists until +infinity. So -3 to +infinity. In behavior on the left, as I move to the left, the lowest x value I can have is -3. So I can't go anywhere past that. As x goes to -3, and as I go this direction, my y values just get bigger and bigger. So y goes to infinity. And last thing on the right side, as my x values get bigger, I can go all the way this way that I want. My y values are going to point down towards -infinity. So as x gets big, y goes to -infinity. Please message me and remind if you need any help with these questions. I think you guys are going to be good. We do have some notes on these that you can look at as well. But like I said, please feel free to reach out to me and I'll be happy to help you. We'll see if I remember how to stop this. Okay, bye.